Section 1.2, Use segments and congruence. One thing I want to point out here before we get going is this little symbol here. That is my quick and easy symbol for and. You've seen it probably, but I just wanted to be sure. It's not a plus sign. It's like this symbol, except sometimes I just write it too fast and it looks more like that. And symbol. First definition, postulate, also called an axiom by some books. A postulate is a rule that is accepted without proof. So it's just a rule. We have different names for different types of rules, and this is our first rule, and it's called a postulate. We just accept that it's true. Next definition is distance. The distance between points A and B, written as AB with no symbols above it, is the absolute value of the difference of the coordinates of A and B. So one thing to note, you are going to have homework and they are going to say that. And you're going to think, what about CD? Well, that is our symbol for find the length of segment CD. So it's really important that you notice that and get used to that notation. So it says the distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. So the length of AB is the absolute value of the difference of the coordinates of A and the coordinates of B. I'm going to erase this right here, and we're going to find the distance between A and B two different ways using this formula right here. So I could find the length of AB, or the distance between A and B, by doing the absolute value of the differences of A's coordinate and B's coordinate. So there's A and there's B. We can just plug them in. Absolute value bars are like grouping symbols. So we're going to get the answer inside first. -2 minus 3 is -5. And then we'll take the absolute value of -5 and get 5. Well, what if you like to do positive numbers first? So when you found the length of AB, you wanted to do B's coordinate and then subtract A's coordinate. Well, it doesn't matter. B and A is the same as A and B. That is the same distance that we're talking about. And so 3 minus -2 is 5, and the absolute value of 5 is 5. That's why those absolute value bars are important. They let us be able to get the same answer whether we do AB or do BA. Okay, another definition here. When 3 points are collinear, remember that means they are on the same line, you can say that one point is between the other two. So here we have 3 points that are collinear. We have 3 points that are all on the same line. And we can talk about this idea of betweenness. It seems kind of easy probably, and you wonder why we would take time for this, but this idea of betweenness is very important in geometry. So we're just taking just a little bit of time to talk about it. So for points A, B, and C, the point that is between the other two is B. That doesn't mean that B is in the middle between them. It just means that it is somewhere in between those 2 points on the line. And that's important here. If we had another line, and you have D and F and E here, can we say E is between D and F? Is E between D and F? No, it's actually not, because this idea of betweenness happens when we have 3 collinear points. We do not have 3 collinear points in this DEF situation. E is not collinear because it's not on the same line. So E is not between. D and F. Okay, we have our first postulate. It's called the segment addition postulate. I will really refer to this postulate throughout the entire year. When we do angles, we'll have an angle addition postulate. When we do arcs, we'll have an arc addition postulate. And this segment addition postulate just comes up in so many different ways and in so many different types of problems. So it's one you definitely want to pay attention to. It says if B is between A and C, then the length of AB plus the length of BC equals what? So let's have this line. We know, because we just wrote down the definition for between, if B is between A and C, then that means that they are all 3 collinear. I'm just going to spread them out like that. It means they're collinear, and B's in the middle, well, not in the middle, is inside the line segment A and C. So this segment addition postulate says the length of AB, so this part, plus the length of BC, this part, equals what? What do you get if you put those 2 parts together? You get the whole thing. AC. And that just makes sense. And we get to use this so many times and in so many different ways. If AB was 3 and BC was 11, could you answer this question for me? What is the length of AC? Or what is the distance between? I'm going to actually say what is the length of segment AC? Well, yeah, we could. But we could use this postulate, A and B plus B and C equals AC. So the length of AC is 14. Segment addition is great. The last thing before we wrap up today is this idea of congruent segments. We have a congruent symbol. It's an equal sign with a tilde over it. Oops. Congruent segments are segments that have the same length. So if AB, the length of AB is the same as the length of CD, then we can say that segment AB is congruent to segment CD. Get used to using the symbols and the notations. Lots of abbreviations and symbols that we can use to make our note-taking shorter.